Lesson 6.1, Discrete Random Variables. The objectives for this lesson is to be able to distinguish between discrete and continuous random variables, identify discrete probability distributions, graph discrete probability distributions, compute and interpret the mean of a discrete random variable, and interpret the mean of a discrete random variable as an expected value, and compute the standard deviation of a discrete random variable. Before we jump into this lesson, let's review what discrete and continuous variables are. If we jump on over to our overview sheet, recall that we have two types of variables, quantitative and qualitative. Discrete breaks down the quantitative, and continuous does as well. So we have discrete as countable and finite, and then we have continuous as infinite. So this chapter we're going to be focusing on discrete, and then in chapter 7 we will work on continuous. So here for discrete, you can see that we have two bubbles that we're going to fill in for this chapter. The first bubble here will be on 6.1, and then over here will be 6.2. So let's define a random variable. It is the numerical measure of the outcome of a probability experiment. Its value is determined by chance. It is denoted by X. So we have seen in chapter 5 like the probability of getting a 6 or a 7 or an 8. Here we're going to denote it as a probability of X is greater than or equal to 6. X is going to be, as we just learned, the random variable. So again, there are two types of random variables, discrete and continuous. And we need to describe the difference. Discrete, again, is finite or countable values. And then continuous is infinitely many values. So let's determine whether the random variable is discrete or continuous. The number of A's earned in a section of statistics with 15 students enrolled, that is discrete. About the number of cars that travel through McDonald's drive-through, that is discrete as well. We can count the number of cars, we can count the number of A's. What about the speed of the next car that passes a state trooper? This is continuous, right? Because we could be going 60.2 miles per hour. We can't say we just go 1 mile per hour or 2 miles per hour or 3 miles per hour. We can go in somewhere in between. So like I said previously, we're going to focus on these discrete for chapter 6, and then continuous variables are going to be covered in chapter 7. So we have done something like this prior. We're going to take it one step further for these examples and list what the random variables could potentially be. So for part A, you could have 0, you could have 1 person, 2 people, all the way up to 15 people getting A's. What about the number of cars that drive through McDonald's drive-through? Again, we have 0, 1, 2, and now we're not going to put an end value on there because we don't know the max number of cars that could go through a drive-through at McDonald's. And then for continuous, well, it has to be a speed, right? So it's greater than 0. So anything greater than 0 is considered a speed. We cannot write equal to 0, greater than or equal to 0, because we are talking about speed, and speed is above 0 miles per hour. So you can see here, continuous variables are denoted by an inequality, and then discrete are just listed as the countable numbers.